Welcome to the first video in this linear programming series. In this video, we will graphically solve a basic linear programming problem using extreme or corner point approach. There are two methods we can use to solve linear programming questions: graphical method and the simplex method. In this chapter, we will see how to solve linear programming question using graphical method. The steps are the graphical methods are: define variables, establish objective functions, establish constraint, draw a graph of the constraint, establish the feasible region, and finally determine the optimal product mix. What we here have is linear programming or LP model. The x and y in this model are referred to as decision variables. They tell us what quantity to buy, produce, sell, or transfer, and so on. The 2x and 5y here is referred as objective functions. These objective functions mean which we want to maximize in LP or linear programming. In linear programming, we either maximize or minimize these objectives. The next two lines are called as constraint. They are restrictions that sharp have you attained the objective. Since we are dealing with real life objectives, we do not expect them to have negative values. So the last line here tells us that both x and y have to be greater or equal to 0. To solve this model graphically, we begin by finding points that satisfy the constraint line. For the first constraint, when x equals 0, y equals 8, and when y equal to 0, x equal to 16. For the second constraint, when x equal to 0, y equal 15, and when y equal to 0, x equal 9. Let's see how we can plot these informations into a graph to derive the answer for objective functions. Now, when drawing the graph, we usually just stay in the first quadrant here, where both x and y are positive because of the non-negativity constraint. So for its constraint, we have the point where x 0, y is 8, and where x is 16, y is 0. We join those 2 points for the constraint line. We do the same for the constraint 2, where x is 0, y equal to 13, and where x equal to 9, when y equal to 0, and then draw the constraint line. Since these constraints are less than or equal to constraint, they will be satisfied in the region below the lines toward the origin. Therefore, the region satisfying both constraints simultaneously is this one here. It's called feasible region. That is, any point in this region is a feasible solution. In particular, the optimal or the best solution will occur at an extreme point O, corner point of the feasible region. These are the corner points for this feasible region. Let label 1 to 4. The optimal solution to this linear programming problem will occur in at least one of them. To decide which one is optimal, we will find the coordinate of the point, plug them into objective function, and then choose the best at a corner point. At corner point 1, the coordinates are clearly 0 and 0. At corner point 2, where x is 0, y will be 8. At corner point 4, where x is 9, y will be 0. Now those are easy to see. We can see that the coordinates for point 3 are 6 and 5 by eyeballing that looking up very closely. But eyeballing is not usually best way to grow up and find the intersection of two lines when drawing graph. So let's see a way to solve the two equations simultaneously to determine the actual coordinations. Here the two constraints. If I suppose to eliminate x, note that coefficient of x here in 2 is 5. Then I can simply multiply is in the first equation by 5 to give 5x plus 10y equal to 8 and subtract c2 from the new equation. So 5x cancel 5x, 10y minus 3, 7 is 7y, and 80 minus 45 gives 35, and on dividing both sides by 7 we have y equivalent to 5, so 5x plus 10y equivalent to 80. To find x, we substitute y equal 5 into any equation. If we choose C1, which means x plus 2y equal to 16, then we have x plus 2 into 5 equal to 16. So answer will be x equivalent to 6. So that x and y coordinates for extreme point is 6 and 5. Next, we determine the optimal solution point by finding corner point that gives the best value of the objective function. In our question, the objective function is to maximize 2x plus 5y. As you see here, the objective function or its value is sometimes represented with z. So now the x and y coordinates at point 1 are 0, 0, and substitute then in the objective function gives 2 into 0 plus 5 into 0, which equivalent to 0 as an answer. At point 2 we have 0 and 8, so function value is 2 into 0 plus 5 into 8 equivalent to 40. At point 3 is 6 and 5, so function will be 2 into 6 plus 5 into 5, which give equal to 37. At final point 4 will give function equal to 18. Now here provide two functions, the value objective function, the objective function. So in order to determine the optimal solution, optimal solutions occurs at point 2 as the highest amount amounting to 40, and its x equivalent to 0 and y equivalent to 8, and the corresponding objective value is 40, and they concludes the solution to this linear programming problem by using graphical method. Thanks for watching.